All right, the 3 dots in the middle are the ones that make up the box. So I usually will put the 3 vertical lines, connect the box, and then draw lines to your minimum and maximum. Those make your whiskers. All right, and then that's an example of a box plot that you make when there's an even number of data points. All right, when there's an odd number of data points, so let's see which one you can do. So like data set A has an odd number of data points. There's 7 total. Either way, the whole process is still the same. What do you have to make sure your numbers are in? From good. So like, for example, if I put this least to greatest, I have, oops, not 3 times. I have 1 as my smallest. I have 3 twice, so make sure you write it twice. Some people thought you only wrote it once. You know, you need to write your duplicates. And then just double check that you included all your data points. So if I started with 7, I should have 7 in my list. What is the 5 numbers that you need for your box plot? Like the names of them? What's one of them? You need a median. You need a minimum. Good, and what else? Quartile 3. Quartile 2 is actually the median of the whole thing. So looking at this first example, even if that wasn't yours, these are the 5 numbers you need. So what is the minimum of this data set? 1. So when I make my number line, I need to have a dot over the 1. What else will get a dot over it from this data set? The maximum, which is good. We have those 2 things figured out. What else would get a dot over it? 4. What does that represent? The median of the whole thing. So when you have an odd number of data points, like we do now, you go left, right, left, right. When you have an odd number of data points, it should just be 1 number in the middle. That's my median of the whole thing. That splits your upper and lower half. So I have 3 numbers in my lower half, 3 in my upper half. Number Q1, median of your lower half. Q3, median of your upper half. So what's my Q1? 3. What's my Q3? 7. And you'll notice the quartiles split the data into quarters. So now I have, there's 4 quarters in the dollar, right? So now I have it split into 1, 2, 3, 4. All right, then that's how you make your dot plot. These, when I make my number line, and since my data goes from 1 to 10, it's probably best to count by 1. 1, 2, 4, 5, 6, 7, 8, 9, 10. That way it doesn't look so like busy. Have a dot over 1, dot over 3, dot over 4, dot over 7, and dot over 10. All right, line, line, line. Pretend that goes through the dot. And then connect the one. All right, easy. Now that we synced up. All right, so I'm giving you no more than 5 minutes to have your final draft done of your data. And then taped to the wall. I'm going to erase this so that we can see all the data in case you lost your little slip. Make sure that on your final copy that you write whatever data set it was, because the rest of the class will need to answer questions based off of that. So it says with the partner or with your group, but it honestly can be individual because you each have your own paper. You're going to look at each of the dot plots and answer these questions. So when you are looking at the dot plots, you're going to look for which data set's greatest value is 10, which data set has the largest range, which data set has a median of 16.5. You're gonna basically evaluate each other's box plots in order to figure that out. Questions? All right, go. One of them you may not be able to see the answer to because whoever had data set B didn't put theirs up, they did someone else's. So I guess you guys will all have to figure out data set B and then answer these questions. All right, go. You have 10 minutes to start out with. And you know, not all of the box plots were constructed perfectly, but let's just kind of hope that we can learn from mistakes and learn from other people's mistakes. One big mistake that I've been seeing is that number line. Your number line should be what? Your number line should be what? Should it be like random numbers? Should it be too big? If my data starts at 3 and ends at 13, what should I probably count by on my number line? Ones, I would agree. So then, let's say for data set B, and I mean, we can start anywhere we want to. If you want to start at 0, you can even. I'll start at 2. And, or actually, let's start at 0. And then I could go 1, 2, 3, 4, 5, and then just label every 5th one, but it's still counting by ones. Each tick mark is 1. 6, 7, 8, 9, 10, 11, 12, 13, 14, and that's really all we need. So I'll put 15 over here. All right, so that probably would have been a better number line to use, whoever had data set B, whoever had this data. All right, but either way, you calculate your 5-number summary, you made your box plots, and now we are evaluating them. You can go. So by looking at everyone's box plot, which data set's greatest value is 10? Give me a letter. Anyone think something other than A? Good. It is A. And you can probably have even figured that out without necessarily having to look around. But whenever you're looking at a box plot, say this, what area of the box plot tells you the greatest value? The maximum, which is that farthest dot on the right. So that's what you should have done for these. Like I can see on data set G, it looks like the biggest is 86. A is 10. C is 21, at least according to your guys' drawing. But you also probably could have just looked at this list and seen which has the largest value. 10. Good. So that is correct. Number 2, which data set has the largest range? Now, I didn't tell you what range was beforehand. Anyone know what range is? Yes? Good. It's your maximum minus your minimum. So, again, you should all be able to figure out the minimum and maximum from looking at a box plot, even without having the list in front of you for whatever their data was. So it would be whatever number it is on this line. So whatever dot number is there, and then minus whatever that one is. So you could have done that on each and every single one. So like for data set A, 10 minus 1, maximum minus the minimum. Our range is 9 for that one. For data set B, what's my maximum? What's my minimum? So my range for that one is like 13 minus 3, 10. All right, so far that's my winner, but I keep going down the line, and which data set has the largest range? A, B, C, D, E, or F? I heard E. Let's see. E, the biggest number here is 137, right? Correct me if I'm wrong. My smallest number is 126. 137 minus 126 is it 11? I'm doing mental math. Yes, it's 11. Now, is that bigger than, say, F? That has a maximum of 80 and a minimum of 50. What's 80 minus 50? So the one that has the greatest range is data set F. All right, and again, maybe there is an error on that one, who knows? But just letting you know, data set F should have had the largest range. All right, which data set had a median of 16 and a half? All right, I heard C. Anyone think something different? All right, that is correct. So C was over here, at least the correct C. That someone labeled their C, but theirs was actually D over there. But C, the correct C is over here. And looking at it, it actually looks more like they marked the median as 17. But it should actually be 16 and a half, which is fine. We'll learn from the mistake. So going to our data for C, remember you want them to be in numerical order. We have 13, 15, there's 2 16s, there's a 17, there's 2 19, and a 21. All right, just making sure I don't forget any. And then to find your median, that's your middle number, right? So just go left, right. And since it's an even number of data points, I have 8 data points. I should have 2 numbers in the middle, which then you'll take the average of. So add them together, then divide by 2. You get 16.5. Questions there? All right, then which data set had the greatest upper quartile value? All right, let's see. I don't know off the top of my head. What's the nickname for upper quartile? Q3, good. So then when I'm looking at a box plot, and I'll put black dots where I would have put dots. Which dots, the first, second, third, fourth, or fifth, would be my Q3 always? Would it be the first one? No. So it would be the fourth one. Good. So you should have been able to look at the right corner of each box and seen what their upper quartile is easily without even having to do any calculation. Let me check the key. And it is E, so good job, whoever made that one. And then that means you must have done it right if they found it easily. All right, which data set's least value is 3? B is correct. You can look at it from the list, but if you're looking at it from the box plot, it would be the first dot, right? So B for having the least value of 3. And which data has the smallest range? Good, and remember that's your maximum minus your minimum. So we did them for all of them so far, aside from these 2 in the middle. All right, this one, the maximum's 86, minimum's 81. 86 minus 81 is 5. All right, that has the smallest range. Questions, comments, concerns? All right, make sure that you keep the paper out. I'm gonna come back and give you points for it in just a second. Or at least while we do the next activity. So what was the most difficult part to plot on your box plot? Was it minimum? All right, I heard median, I heard quartile. All right, this is more of an opinion question, but the median and the Q1 and Q3 actually require some calculation, so I can see why those would be the most difficult to plot. I think that's so. Just keep your paper out. I'll come by and check it here shortly. Now we're going to move on to the next activity. All right, so this is going in the grade book, by the way. It'll be our first assessment. So yeah, we're not doing a whole lot of quizzes or separate assessments in here. It's mostly project-based. And so any like activity or project that we do will be put into the assessment category. Friendly reminder, I'm still updating grades. So just make sure that you look at any days that you missed or days that you maybe slacked off on and get those missing assignments turned in. Now let's recall how to create dot plots. So if by the end of today, you can construct a dot plot and interpret a dot plot, then you will have met the requirement. I will also record that, and actually I'll record it separately. And then friendly reminder, in algebra, you have a quiz over lessons 1 through 5. So make sure that we're getting caught up in Schoology. If we were absent, that we're reviewing anything that we may have missed. It's all in there. So that will be Thursday, your first quiz in algebra. All right. So now let's do a notice and wonder. And I don't have anything for you to write on. I don't think you need to write this one down or today's activities down. But we have data from 200 students who flipped a coin 100 times and recorded the number of heads that are flipped. So think for a minute, what do you notice about the data and what do you wonder? Just quietly think that, no talking yet. Oops, I didn't mean to do that. What do you notice and what do you wonder? All right, time is up. What is something that we notice about both of the data, whether it's in a dot plot or in our frequency tables? Yes. 51 is the highest frequency. What else do we notice? What was that? Yes, look at the dot plot. Like here's 50, 51 would be here. It's the tallest. Good. So looking at the table, there's more double-digit numbers than single-digit numbers. Anyone else notice something? It can be as simple as What seems to be the smallest frequency? So any of these that have just one could be considered the smallest frequency. Other things that you could notice are the number of data points. It says that 200 students flipped a coin 100 times. Well, does this add up to 100 or does this add up to 200 dots? All right, that's also something that you could notice. Hold on, I'm on the wrong page. Let me get where I'm supposed to be. All right, some other student sample responses is that the sum of all the frequencies is 200. So if I were to add all of these up and this plus this, it would be 200, which is how many students were part of this experiment. And the 51 is like heads or tails, by the way. Is it how many heads were flipped or how many tails were flipped? Heads. All right, so what are some things that you maybe wonder? So why did they only graph how many times that they have heads? How many sides are there to a coin? 2. So wouldn't you think that the frequency, the highest frequency would have been 50 rather than 51? So maybe that could be something else that you wonder. So why isn't the highest frequency 50? And so forth. Anyone else want to add? All right then. So what we will do, and we might modify this because I don't know if you want to stand in the hallway and make a human dot plot. I think out of the 3 representations we've learned so far, I feel like dot plots might be the easiest. But we are going to create a dot plot that represents some data. And it could be like the shoe sizes, if you want to do the shoe sizes again, or have a few options for you. It could be how many pets are in your household. It can be how many siblings do you have? How many articles of clothing do you have on right now? I feel like that one would be fun for Tacky Tourist Day. How many days could you go without talking? So what we will do is I'm going to put up a pair deck code. So one from each group, pull out your Chromebook, and we're going to create a dot plot using some data from us as a class. All right, good. So these are examples of some good dot plots. Again, if we change the question, then the data changes, which we'll explore more tomorrow. And we'll also finish the pair deck tomorrow because there's a lot of fun slides in here. But yeah, so